A Chinese rover that landed on the moon's surface 2 years ago has found tantalizing clues to the period of lunar volcanism in 40 years while discovering a new moon rock. Chang'e 3, an unmanned lunar mission, that touched down on the northern part of the Imbrium Basin on Moon, one of the most prominent of the lava-filled impact basins visible from Earth, has spotted volcanic rocks unlike those returned by Apollo and Rover missions. We now have ground truth for our remote sensing, a well-characterized sample in a key location, said Bradley L. Jolliffe, the Scout Rudolph Professor of Earth and Planetary Sciences at Washington University in St. Louis. He is a participant in an educational collaboration that helped analyze Chang'e 3 mission data. We see the same signal from orbit in other places, so we now know that those other places probably have similar basalts, he added. The basalts at the Chang'e 3 landing site also turn out to be unlike any returned by the Apollo and Luna sample return missions. In 2013, the Chinese lander touched down on a smooth flood basalt plain next to a relatively fresh impact crater now officially named the Z-Way crater that had conveniently excavated bedrock from below the regolith for the U-2 rover to study. Because Chang'e 3 landed on a comparatively young lava flow, the regolith layer was thin and not mixed with debris from elsewhere. Thus, it closely resembled the composition of the underlying volcanic bedrock. This characteristic made the landing site an ideal location to compare in-situ analysis with compositional information detected by orbiting satellites. The diversity tells us that the Moon's upper mantle is much less uniform in composition than Earth, Jolliffe noted, adding that when correlating chemistry with age, we can see how the Moon's volcanism changed over time. The American Apollo 1969-1972 and Russian Luna 1970-1976 missions sampled basalts from the period of peak volcanism that occurred between 3 and 4 billion years ago. But the Imbrium Basin, where Chang'e 3 landed, contains some of the younger flows, 3 billion years old or slightly less. The newly characterized basalts reveal a more diverse Moon than the one that emerged from studies following the Apollo and Luna missions. Remote sensing suggests that there are even younger and even more diverse basalts on the Moon, waiting for future robotic or human explorers to investigate, Jolliffe concluded in a paper published in the journal Nature Communications.